Hey Scott, that's a great problem. I love it. Jeepers, I might have to steal it. I don't know. That was awesome. Anyway, you're very close. So the thing, if you throw a ball at, so I'm going to assume that Peyton throws it at about 45 degrees, which is probably what he's used to. So if you throw a ball at 45-degree angle, you have to break this into a problem involving the x and the y components. So you've got to say, well, how fast is the ball moving horizontally, and how fast is the ball moving vertically at the time it leaves his hand? And so if this is 45 degrees, this angle 45 degrees, and you assume this is 81 feet per second, you can show using some elementary trigonometry that the two legs of this triangle, which since that we're assuming that's 45 degrees, are equal. They are about 57 or so. So 57 feet per second is how fast the ball was going up, and 57 feet per second is about how fast the ball was going horizontally. So you actually have two functions. One function tells you how high the ball is at any time, and so I'll call that y of t. And you are correct, that is going to be negative 16t squared plus it's going to be 57t plus the 330, which is your initial height. And so that's the function that governs the height of the ball, and you can figure out the vertex of that parabola, which is right here, which tells you how long, that'll tell you how long it takes to reach its maximum height, and you can figure out when it reaches its maximum height. The other equation is the horizontal position, which we call x of t, and since it doesn't accelerate in the horizontal direction, that how far it goes horizontally is just the 57, the horizontal velocity, feet per second, times the time. So figuring out how far the ball goes horizontally would involve solving the y problem for the intercept to figure out at what time it hits the ground. And then once you know how long it's in the air, the time that it hits the ground, you could substitute that into the x equation and figure out how far it went horizontally. But that's a great problem. Let me know if that gives you enough help or if you need a little more guidance on that one. Good find.